Alright, we are going to talk about complex numbers today. We just got through with imaginary numbers, and we're going to start by talking about how to do addition, subtraction, and multiplication with complex numbers. And they're going to be much like what we do when we are dealing with linear binomials like 3 plus 4x or 2 minus x. If we were to add these guys, right, if I was going to add these two things, I would add my x's and my whole number. So I would say 3 plus 2 is 5, 4x and negative x is positive 3x. I'm going to subtract, I'm going to rewrite this. So this says subtract this from this, so it says subtract 3 plus 4x. From that I'm going to subtract 2 minus x. Alright, so when I do something like that, I'm going to have to distribute first. 3 plus 4x minus 2 plus x. If you remember to take that sign into both, I got 3 and negative 2, which is 1, 4, and 1x. 4x and 1x are 5x. Then we got multiplying them. So remember, we have to distribute both terms when we multiply. So if I distribute this 3, I get 6 and negative 3x. If I distribute this 4, I get positive 8x and negative 4x squared. Both terms have to go through. And I'll keep my negative 4x squared out front. I'm going to take this negative 3x and 8x, like terms, and say 5x. We'll put my plus 6 at the back. So, given the same thing, right? Given the same thing, what if we're going to do all this with imaginary numbers? What if instead of 3 plus 4x, it was 3 plus 4i? And instead of 2 minus x, it was 2 minus I. Well, we have like terms still, right? So if I was going to say 3 plus 4i plus 2 minus I, the 3 and the 2 are the same, and the 4i and the negative I make 3i, much like when they made 3x up above. I can still see that on this, right? When I subtract, let's order this up. So I'll still say 3 plus 4i minus 2 minus I, and I still have to distribute the negative 2 and the positive I, and I get the same thing. I get 1 plus 5, but instead of an x, I get I. In fact, maybe the only difference is that we worked out powers of I last time. So as I distribute this, I get 6 minus 3i, and as I distribute this, I get positive 8i, and now I get negative 4i squared. If you think about it, right, it's almost the same, but I know this. I know negative 4, and I know I squared is actually negative 1. So the I squared turns the sign of this constant here into a positive 4. So now I've got 6 plus 4 is 10 plus 5i. There we go. So we're going to have to know that I squared is negative 1. We're going to have to know that. We're going to use that quite often now. Let's go to page 2. Alright. Now, complex numbers are any numbers that form an A and a BI, where A and B are real numbers, and I is a imaginary part, square root of negative 1. A is the real part, and BI is the imaginary part. Together, they're part of a group of complex numbers. So I want you to see something, that when I put a real and imaginary part together, they're complex numbers. Only complex numbers. Real numbers, which we've actually dealt with this system for years now, are also complex, and imaginary numbers are also complex. So it's really just a bigger system, right? So we've taken what we knew about real numbers, we've added imaginary numbers, and we've put them in a larger network of numbers called complex numbers. So if we come down here, it says identify real imaginary parts of the given number, then tell the most specific. Alright? So we've got real, which is 9. We have imaginary, which is 5i, and these are complex numbers. They can't be totally in the real, they can't be totally in the imaginary, so they're, ooh, I should put an M in there, complex. This one, right, the real is a 0, it doesn't exist, right? Imaginary equals negative 7i, and although this is complex, it says only the most specific, so we're going to say imaginary number. This guy right here, the real part equals 11. The imaginary part is 0i, and it is a real number. Alright. This guy right here, it has a real part, negative 1. It has an imaginary part. I'm going to shorthand this one, which is just I, which makes it, since it's got both parts, it's a complex number. Alright. Coming down here, we're going to go here and get a little bit more. This is a little bit longer, but let's keep going. So to add and subtract complex number, you add and subtract the real parts and imaginary parts. So I'm going to take the negative 7 with the 5 and make negative 2. Make the positive 2 and the negative I and make a negative 9i, and we're done. Same concept here, except I have to distribute my negative, and then we add them. 18 and negative 2 is 16. 27i and negative 3i is 24i. And the sum here, we've got a and a is 2a. bi and negative bi don't matter, right? So is this real or imaginary number? This is a real number, right? Because my imaginary numbers canceled out. Now, there's just a little bit more here. I'm going to keep going. Your turn. So if you want to pause this, then check your answers with me, or just look up when you're done. I'll say when I'm done. I will go done, and we're going to come back, and you know what? We've got enough time. I think I'm going to do this whole page. Here we go. So I'm going to start. I'm going to do it quietly, and you can look up when you're done. If you want to pause and check C and D, the answers are there. I'm going to show you how to multiply complex numbers now, and really the main thing you got to remember is that I squared is negative 1. So as we distribute through, 4 and 6 is 24. 4 and negative 2i is negative 8i. 9i and 6 is 54i. 9i and negative 2i is negative 18i squared. Remember this negative 18i squared, I squared is negative 1, so that's going to turn that into a positive 18, right? Because I squared is negative 1. So this gives me 24 and 18, which is 42. Negative 8i and positive 54i is positive 46i. I'm going to do one more right here. Alright. Distribute through. We've got negative 3 and 7 is negative 21. Negative 3 and 4i is positive 12i. 7i, or 12i and 7i is positive, what is that, 84i. And 12i times 4i is positive 48i squared. If you remember, I squared is negative 1, so that's going to make that a negative 48. A negative 48 combined with a negative 21 is negative 69. Plus 12i and 84i is 96i, and I'm going to circle those. Alright? So look at this guy. They're going to show us something we're going to get very used to, right? That's a pair. It's a conjugate pair right here. Watch what happens here. If I distribute, that gives me a squared. And this right here, notice they're the same except for the sign in the middle, is positive abi. Sorry, that's a negative abi. And this next one is a positive abi. And this last one is, well, we've got negative bi squared. Well, the middle terms have opposite signs, so they cross off. Remember, I squared is -1, so that's going to turn that into a positive b, and we get a squared plus b. So I'm going to do these. You do your turn. We're going to pause after this, and just check your answers. If you want to pause, I'm going to go pretty quick. Alright, I am done if you want to check, and that's going to be it. But that's 3 pages done. Talk to you soon.